Okay, so I will be discussing the research article Interactions between Zooplankton and Crude Oil, Toxic Effects, and Bioaccumulation of Polycyclic Aromatic Hydrocarbons. So the main objectives of this study were to investigate the effects of crude oil to survival and bioaccumulation of polycyclic aromatic hydrocarbons in mesozooplankton communities. Mesozooplankton communities are those zooplanktons that range from 200 micrometer to 2000 micrometers in size. So the second objective was to assess the lethal effects of dispersant and dispersant-treated oil on mesozooplankton communities. So dispersant is actually a chemical used to disperse the oils or crude oil leakage. And third is to estimate the influence of UVB or the full radiation spectrum on the toxicity of dispersed crude oil to mesozooplankton communities. The objectives 2 and 3 were addressed using a shore-based crude oil exposure experiments. Then for the fourth objective was to examine the role of marine protozoans and the sublethal effects of crude oil and in the bioaccumulation of polycyclic aromatic hydrocarbons in the copepod Acacia tonsa. So in this experiment, the researchers used a lab-based crude oil exposure experiments at different food regimes because Acacia tonsa eats or consumes smaller zooplanktons, and then those zooplanktons can actually accumulate crude oil and dispersant treated oil in their bodies. So this is the result of the effects of crude oil to survival and bioaccumulation of PAHs in mesozooplankton communities. So in the first table, table 3, original number from the article, which is the mortality and narcosis of natural mesozooplankton communities. So this table actually tells us that when you increase the concentration of crude oil in the seawater, the mortality of the mesozooplankton communities and also increases. So for the second graph, for the graph, this actually tells us that the median lethal concentration required to kill half of the members of a tested population is 31.4 microliters per liter of seawater after 16 hours. So that's how lethal the oil is, crude oil is to mesozooplankton communities. So for this experiment, for this graph, this is the lethal effects of crude oil, dispersant, and dispersant-treated oil on mesozooplankton communities. So it showed that there is a significant difference in mesozooplankton mortality among treatments. So the treatments is actually the crude oil and dispersant, and lastly dispersant-treated oil. So it showed that mortality is the highest in the dispersant treated oil, which is actually funny. Kay the dispersant that is used is the one considered to be the least toxic among all the dispersants. So at 72%, then at the dispersant alone, 48% crude oil, then 21%. So in the second graph was actually it showed that only the UVB radiation increases the lethal effects of dispersant treated. Experiment UVA and UVB was compared, and it showed that UVA, or the absence of UVB, does not actually affect the mortality of the mesozooplankton. So for for this experiment, this is the bioaccumulation of PAHs in natural copepod assemblages exposed to crude oil. So this table actually shows that the concentration of polycyclic aromatic hydrocarbons in exposed copepods is 2.5 to 10 times higher than those that are not exposed because of the copepods or the mesozooplankton, because copepods are naturally exposed already to crude oil, and that the highest concentration of polycyclic aromatic hydrocarbons in the crude oil is the fluoranthene, and followed by pyrene. and that there is a significant difference in the bioaccumulation factors of fluorantine, phenanthrene, pyrene as crude oil concentrations increase. Kay, it was explained in the discussions section that this is naturally, chemically, based on the chemical composition of the polycyclic aromatic hydrocarbons. So for the results of this experiment, the bioaccumulation of PAHs on acacia tons at different food regimes is kuan kanang unsa ni, that the total concentration of PAHs in a tonsa feeding in Rhodomonas was 1.4 times higher than in exposed copepods. So okay, so as what I was telling earlier, that your that your mesozooplantons actually eat those smaller zooplanktons, and those zooplanktons, so smaller zooplanktons eat kuan phytoplanktons, and kanang kuan the bioaccumulation of crude oil actually kuan kanang happens from phytoplankton then to microzooplankton then to mesozooplankton, because the smaller the organism, the more likely would be the crude oil to attach those surfaces that kuan exposed to kuan crude oil. And when you eat something, you get by the kuan nutrients, and of course the waste that that food has. Okay, so the the results of this study showed that the okay, so for the results of this part of the experiment, the total concentration of PAHs in a tonsa feeding in Rhodomonas alone was 1.4 times higher than in exposed copepods. This is actually expected because your Rhodomonas will absorb the crude oil present in the water, or in the seawater, or in the medium. Your pH is also in Atonsa incubated with Oxyris marina, which is your protozoan phytoplankton, and your Rhodomonas sp was 1.6 times lower in exposed to oil than in controlled. This is because your Oxyris marina absorbs the crude oil and then expel those crude oil into non-edible fecal pellets. That is why it's 1.6 times lower, and that the total concentration of PAHs in body tissues of Acacia tonsa incubated with Oxyris was 2 times lower than those incubated with Rhodomonas. It's also expected because your Oxyris gani kay murag i-lessen niya ba ang crude oil available for the Acacia tonsa. Then the concentration of all the PAHs in the body tissue was lower in experimental treatment with Oxyris rhodomonas than in the Rhodomonas alone. Kay the presence of Oxyris greatly affects the rate of absorption of the Acacia tonsa to the crude oil. And the graph to the right, or in the right part of the this presentation, is that egg production kono rate and the egg hatching rate is lower in the experimental, because kanang your Acacia tonsa cannot function very well because of the presence of crude oil man. They undergo extensive homeostatic kuan mm, kanang process. And also the fecal pellets production rate is higher in experimental because the metabolic processes of your Acacia tonsa increases to expel those crude oil present in their body tissues. So here are my remarks of this research article. Okay, so the results of the experiment were consistent with that of Ozan et al. 2014, Bosque et al. 2016, Tang et al. 2015, and Almedo et al. 2014, and lastly to Rauscher and Tartrutti 2011. So this These were the tables or graphs from Almeida et al. And Raucho Tartrote. Unfortunately, I was not able to get graphs or tables because the other researchers only stated it in their research article. No graphs or tables were present. Okay, so the article was also written objectively, but although first person pronouns are observable, and also in the table 4, the concentrations used in station A was not explained why it was different from the rest. Okay, so this is what I was telling. Okay, so in station A, the crude oil concentration is 0, 25, 50, and 100, while for the stations B and MRM is 0, 10, 20, and 30, while the mortality and narcosis is kuan ka ng the same there with the rest of the stations. Also, the methodology of the research article was very detailed and was able to address the objectives. This is a positive feedback because a very detailed methodology usually is very easy to follow and to replicate. There are also uncited reference entries, for example, entry number 70, 84, 94, 106, 129, and so on. This is because maybe in the methodology section, the journal or the journal did not allow any in-text citations in the methodology section. There are also semantic errors. The author used the word threated instead of treated on pages 2 and 4. The graphs and tables also aid the readers to understand the article more easily. And aside from this minor kuan kanang remarks that I have, the article is nonetheless very informative and could actually help the future scientists or the researchers and the whole academe at large. And that would be all. So I'm gonna end